This is Dr. Keith Duggar. He's with Microsoft. He's a principal industry strategy director, and he's also a Georgia Tech alum. I was kind of blown away when I looked at his background. He was a chemical engineer, got his bachelor's here, did it in 2 years, which is crazy. Went on to get his PhD at MIT. Has worn a lot of different hats. It's just impressive. Software development, a quantitative data analysis, a web developer. He's done work in the financial world with arbitrage. I mean, he's, most currently he worked with Microsoft for the last 3 years, but he's been doing work in this area for over 20 years. And now he's primarily working with enterprise manufacturing companies, basically making their supply chain smarter, connecting them, just helping with digital transformation. And with that, I'll turn it over to Keith.
Yeah, thank you. So, yeah, all that's pretty accurate. I guess I was in a hurry to get out of here, but subsequently I realized what a gift it was to be here. And actually, it's really a pleasure for me to be back at Georgia Tech. It's been quite a while since I've even been on campus, other than maybe driving through to take a peek at how much has changed. But definitely some of the best years of your life here. For sure, some of my fondest memories belong to this campus. Though now that I think about it, some of the haziest memories also belong to this campus. I'm sure they were fond, though, if I could remember them. So it's really a pleasure to be back here, and it's honestly quite humbling because 25 years ago when I started as a student here, I would have never expected that I would have anything of interest, let alone value, to say to one of the top supply chain and logistics universities programs, right? So I hope you find some of what I had to say interesting and hopefully valuable. But more important to me is I hope this inspires some further and deeper dialogue between Microsoft and Georgia Tech. Because while we do a lot and we build a lot of tools and a lot of services and platforms, really the goal is to enable people like you to build the future systems, right? And the research that you do to take that and bring it out into the world and let it provide value for all of us. So how many of you have actually ever used Azure before for your work or research? Okay, a couple people. How many think they might want to use it? Or, maybe would like to learn more about our tools that we have to offer there. Okay, not enough of you. We've got some great stuff. And listen, I'm no Microsoft fanboy, okay? As you heard, I have quite a varied background. From like 1994 until 2014, I could care less what Microsoft was doing. They were doing nothing of interest to me at all. I was a hardcore Linux, Unix-like guy doing, working on Wall Street, building quantitative trading algorithms. If you saw my workstation, it was Linux with a whole bunch of MWM windows and things like that set up. If you even know what that is, Motif. So I'm not some type of shill for Microsoft, but I can tell you that I'm there because I found out they were doing some really cool things in artificial intelligence, machine learning, Internet of Things. And I'm also quite a skeptical anti-hype person. So anything that's on Gartner's sort of hype cycle, I probably initially hate it, right? So IoT, I didn't care about. I'm like, IoT, schmIoT, whatever, don't care, okay? But as I started doing research on it, I realized that if the internet was the biggest revolution of my lifetime so far, Internet of Things takes that and connects it to the physical world. Think about that. That has tremendous potential to improve life, improve productivity, health, well-being, right? So exciting things are happening at Microsoft, and I encourage you to learn more about Azure, maybe branching off from some of the things that we talked about here. And you might have noticed that, that over the last 5 years, there's kind of been a big change in Microsoft's, let's say, orientation towards the world, right? It's much more open now. It's much more, hey, we like Linux, we like Windows, use both, use either. You know, we're into open source. You know, we bought GitHub, right? We're one of the largest contributors of open source today. You've probably seen our commercials saying that we're about democratizing AI, right? Our mission is to empower every organization and individual on the planet to achieve more, okay? And these are actually real concepts that have grown out of Microsoft's journey. And part of that is that we've learned that customers, the consumers of the things that you produce, are where your focus should be. Prior, you know, we focused on the product. We focused on the things, the systems. And here, take it or leave it. Here's Word. Do you want some? You want some licenses, some seats? But we realized, no, it's really about the users, the customers, the consumers, that the long-term success of Microsoft hinges on the success of our customers, right? And so when we think about a supply chain, you know, we recognize, sure, there's a chain, you know, that there's some raw materials at the very highest upstream, and there's a chain and it gets converted. But what's happening at the end, somebody's using that, right? And they actually can feed back into this process. So we think more about sort of these connected economic loops, okay? So for example, you know, you've got customers using your products, and they can actually, through sensors or other telemetry, let you know about their demand. So you can deliver things before they even need to ask for it, just automatically, right? Through their feedback, it can actually influence your design of the products. I mean, we know this happens, right? Products do improve, but what we're talking about is accelerating that cycle and collecting much more data about the usage of your products to do an even better job of designing them. So this is kind of the, you know, the philosophy of Microsoft in supply chain, is that it's this loop, and the customer and the consumer plays a pivotal role. And when you think about it, in every link of your supply chain, those supplies are actually also connected products. Or if it's a connected supply chain, they would be connected products, right? Because almost every supply is produced by somebody, and they probably care about the same types of things that you do for your products. So the links in the chain are connected products from one direction, and a connected supply chain from the other. So as we kind of go through the presentation today, and by the way, you know, as you know, I'm sure, supply chain logistics is a vast topic. Okay, I've done my best to kind of pull together some things that I think are interesting in this presentation. It's only the tip of the iceberg of what's out there, or even what Microsoft is doing, okay? So afterwards, I'm going to be around for a while. Feel free to reach out to me, and I hope we can have conversations in the future as well. Now, IoT, Internet of Things, we think plays actually a pivotal role as well in connected supply chain. You know, it obviously plays a role in connected product, right? Because you're producing a thing and it's going out. And if you want to get back information from it, that's Internet of Things. And as we just realized, connected products are the links in a connected supply chain. Ergo, IoT is an essential component of connected supply chain, right? Because you've got to have these sort of loops of information flow from the users of your products, from the operations of your factory, et cetera, all kind of feeding into the system of intelligence. Because otherwise, all you're left with is like what we have now, or what a lot of people have now, just these kind of silos sitting around, kind of doing their own thing, not communicating. So you don't have the totality of the information to gain knowledge, which is required for intelligence. Intelligence is knowledge plus action plus control, right? So where do you begin? What does kind of a journey through sort of creating connected systems of intelligence, connected supply chains looks like? Well, first, you've got to connect things. You know, I know this seems kind of simple, maybe obvious or easy or whatnot, but never confuse simple with easy or simple with trivial. There are many simple things that are very valuable and took humanity a long time to figure out. It's like E equals MC squared. That's a simple equation. How long did that take? Right? And there's many examples I could give you. Does anybody know how to tie knots really well? Big knot tire? No? Well, that's one of my hobbies, and I try to train people to tie knots. These simple knots, very difficult to tie correctly, believe it or not. Okay, so just connecting your data, your devices, your machines, your people can deliver tremendous value to an enterprise that isn't already connected. Just being able to see your data. Okay, I've worked with customers who, for example, for the first time that they saw the telemetry from their machines, one of their engineers immediately saw, oh, we're running this thing at the wrong speed. We could improve it by altering how we accelerate and do this, speed, whatnot. Just from seeing the data sort of correlated for the first time. The data of the machine speed combined with production. Step number 2 is, well, I've got all this data. Maybe I can get some knowledge from that, build some models, and predict things, right? If it's connected, I can see when something is happening now, but I'd like to be able to tell you before it happens. That's predictive. And then the next step, cognitive, is if we know something's going to happen, what can we do now to control the future? What can we do to change it? What actions can we take to mitigate what's about to happen? Maybe I got some bad raw material some raw material that has specs that aren't optimal. pH is out of bounds or something. Well, if I know that and I can predict what the effect is on my process and maybe add some mitigating chemicals at some stage and save the batch, right? That's cognitive. Taking knowledge and converting it into action. And there's sort of lots of steps along the way. You can break this down into for essentials, you've got IoT and you have to worry about things like security and privacy and multi-tenants. Like a lot of manufacturers are very cautious of having their data even theoretically accessible by some other manufacturer, right? Remote monitoring, being able to see things out in the field. Okay, like you have an oil tanker coming across the ocean. There's not a lot of connectivity out there. How are we going to see it, right? Connecting people. People are a central part of this journey, right? Connected field service, being able to send people out into the field to do things. Predictive maintenance, asset performance management. So predictive maintenance, it isn't just about fixing breakdowns or preventing breakdowns. It's about making sure that your process is running the best that it can, right? That's a lot of what maintenance is about, right? I maintain my car so it doesn't break down, okay? And then you get into supply chain visibility. So now we're saying go beyond your little sphere to all the systems that you interact with, right? And then big compute. You're going to have to do some analysis. Maybe you want to do some job optimization or job shop optimization problem. And who knows what that is? Job shop optimization. No? What are you teaching here, right? It's a very hard mixed integer linear programming problem, right? For which it's computationally extremely difficult as you start to get more nodes. It's about how do I schedule all my production across machines and logistic planning and whatnot to get the optimal solution, right? Then you can think about digital twins. What's a digital twin? Well, I don't know. There's lots of people with different ideas. I'm going to tell you what I think the right idea is. And it's almost literally a quote from the Matrix, but I'm not going to try to quote it because it is wrong. It's the digital representation of your virtual self, but in this case of things. Okay, so if I have a machine in a factory and it has a bunch of digital data and information about it, I represent that digital self as a digital twin, okay? And I want it to, in real time, so I'm not going to go down that box. I have strong opinions there too. In real time, I want it to reflect the state of this machine. And furthermore, if any of the things on the digital twin are modifiable by me, I need to have in place the control structure to affect that change on the device. That's a digital twin. So now we're talking about sort of minority report type, change my machine here and do some tweaks, and it's all fed back through control circuits to the actual devices. Make sense? Yeah? Now, Microsoft, didn't just kind of pull all this stuff out of thin air. Okay, number one, we have many, many manufacturing customers that we work with all the time, all the largest manufacturers in the world, small ones, medium, everywhere, okay? But how many of you actually think of Microsoft itself as a manufacturer? Anybody? Anybody play Xbox? We make that. Anybody have a Surface of some type? We make those, okay? We manufacture hardware. We are a hardware manufacturer, okay? In fact, it's to the tune of like billions of dollars, right? 200 million units shipped in the last year. 1.3 million locations, et cetera. You can look at these statistics. We are a manufacturer. And there came a point where our own manufacturing system and ecosystem that spanned the whole world became such a mess that we felt like we needed to digitally transform our own manufacturing. So we were facing all kinds of challenges like, pricing, margin, the usual things. But how about this? Increasing customer expectations. I saw some analysis by one of the consulting companies. I forget the detail, but it was something like by 20 whatever, customer experience is going to replace product quality as the number one determining factor in what they buy. Okay? So, we have much higher demands now on the service that we get from products. Okay? This huge network, shortened product life cycles. We got to compete, right? New updates, new everything, faster, more. So all those pressures caused us to say, hey, look, this system that we have that kind of looked like this mess over here, we're like, all these sort of joint design manufacturers and critical suppliers, and like email was sort of the method of communication between all of them. Got some emails here, take this file, go do something with that file, giant Excel spreadsheets, SAP was there as well, SQL, okay? Just this whole huge mess. And we figured we need to change this. So we went over to kind of that situation. And what's unique about the cloud is, look, if you need different entities to communicate, what makes sense is a hub and spoke mechanism. Okay? Despite how fancy mesh sounds, that's not the solution. You can even kind of mathematically prove that, if you have unreliable connections or slow connections or something, meshes are mathematically inferior to hub and spoke because, you have communication failures between a node, and now what happens? Right? So cloud is the hub. Why? Well, first of all, huge investments go into making cloud reliable, scalable, secure, et cetera, et cetera. Take advantage of that, right? And it has all the tooling in order to allow different people, different entities, let's say, to access it, right? So we built this cloud-based solution, where all the kind of actors in our supply chain would communicate to the cloud. And in there we could build automated systems and data factories and analytics and communication. Like, for example, Microsoft has this product called Logic Apps. And I don't know what the current count is, but Logic Apps is just a connector layer, a glue, okay, that has APIs for like 200 and some odd third-party products, everything from Oracle to Twitter to Gmail to Slack, okay, that lets you kind of graphically build, or you can also write JSON configuration files, easily connect to these APIs without needing to learn the API. It sort of unifies the API environment, right? So in the cloud environment, it becomes much easier to connect up all these disparate actors. And once we had that, we could build sort of this thing over here, which is like this. This is a view from the master control kind of room somewhere in Redmond. where they can kind of sit and get a total view of what's happening at Microsoft. And not only that, but they can have all these customized dashboards. So that's one dashboard, but maybe other people want to see different dashboards. Maybe different kinds of managers need information displayed in a way that's optimal for them. And by the way, I said I'm no Microsoft fanboy, but even before I went to work at Microsoft, anytime I saw Power BI stuff, I thought, that looks really good. Power BI is a nice product, right? It produces really nice visual representations of things, kind of out of the box. And now I've learned how to use it, and it's easy to build those, actually. Like something like, this over here, you could build in a couple hours, or, depending on how, I'm not that good at it, because it's only one of the things I do, but it would take me a couple hours, but we have people that take them 20 minutes, right? So you can customize the information presentation so that people's time is optimized. Okay, because, a lot of this is, and somewhere I got a slide, maybe we'll get to it later, but a lot of it's about making people's jobs better and more enjoyable. This is kind of like this whole change management thing crops into supply chain work as well, because people are afraid. Whoa, you're bringing in some technology here. Like, have any of you seen the movie Office Space? Yeah? Like when they're asking the guy what he does. Well, I take the specs and I give them to engineering. Okay, so you actually write down the specs. Well, no, Carly does that. I walk them down. So you just walk a piece of paper down. And he's like, I deal with the GD customers, it's like, I'm a people person. So he's getting scared that he's going to lose his job, right? But it's not about that. It's about augmenting the job so that those people can do things they actually want to spend their time doing. Like doing the things that people are good at that machines are not good at, right? It's about making all of us more productive, life better in general. And so you have to have these kind of conversations. That was kind of an aside there, a track. It's probably going to come up in some slide later, so just remember that. But here are some examples of what we were able to do once we had that data. We could do all kinds of things like with predicting patterns, for example, when we choose what type of chips to use in a product, being able to project what the cost of that chip is going to be over time, and optimizing, reducing scrap. That's a big one in manufacturing. Manufacturing margins are often so lean that little percentages of scrap reduction is valuable. Returns, like I said, customer experience is going to overtake other aspects as the number one competitive factor, right? And we were able to come up with a machine learning thing that with 80% recall could tell whether or not a device was going to be returned. So we don't ship it. Okay? Not only did we do that, but we also decided, hey, we've got this global system here. What about transport of materials? So we partnered up with forget the name of the consulting company. I'll have to look it up. But to create this system or use this system called Navisphere. Have you ever heard of that? Navisphere Vision. So we integrated Navisphere Vision's product into our data stream so that we could see worldwide, where all our stuff was, all our containers, whether they were on time, whether they were going to go through bad weather. Okay. Now, I don't know how useful this actually is, but it's cool to look at, right? I don't even know what all the color codes are, but they do. And it's useful to them to be able to kind of add that human element of, this weather pattern is probably going to cause us some problems here. Because we haven't yet gotten to the point where we can kind of do that analytically, although we can do it with traffic. So here's, it has like integrated traffic for the trucking routes. And visibility into whether things are on time and all that. This is a connected supply chain, okay? The Microsoft manufacturing story, as far as I know, and I have a very limited Hopefully some of you in the audience can tell me. You know, I'm hoping to learn more from you than you learn from me, okay? But it's one of the most connected supply chains that I know about, is our own internal manufacturing story. So we kind of talked enough about that. Now I want to talk to you about a different supply chain. Maybe the oldest, maybe next to clothing or something, the oldest, you know, most fundamental supply chain, food, agriculture. And Microsoft has this product, or not a product, a project and a set of products called FarmBeats. I encourage you actually to check it out. Really cool work. You know, I'm going to show you some of it, but it's a neat project as well to learn more about. Here's sort of the some statistics about the challenges that we face in food. You know, we're lucky here, but in other parts of the world, there's still significant food challenges, right? And things could be much better, and as the population grows, we're going to have to find some way to deal with it, right? Or if climate changes too much here and there, right? We've got to improve our agricultural systems. So there's a lot of opportunities here. Connected farms, you know, cognitive advisories, precision farming. That's kind of about actually not only what it says there, irrigation, fertilizing, weeding, spraying, et cetera, but actually, believe it or not, selecting or engineering seeds for specific microclimates. Okay, because even, like, let's say you got a field and you know you own this 5,000 acres and it's nice and flat and everything, but right over here is some forest. Or maybe there's a hill over there. It creates a microclimate on your soil. Okay? And for a section of your field that's kind of in a shadow or whatever. And you can actually engineer and choose, you know, seeds that will be more optimal for that microclimate. Okay? So there's huge opportunity, but one of the big problems with farms is they're remote. Like there's no cell phone service in a lot of them, you know. How do you get data out of the farms, out of the fields? That's what FarmBeats is about. Okay, it's an end-to-end system that enables this collection and utilization of data. And how do we do it at Microsoft? Oh, by the way, we have a farm. You know, we're not just a manufacturer, we have a research farm. So we grow food too, but you know. This device here is a device that has a bunch of sensors on it, okay, like it says temperature, pH, wind speed, direction, moisture. It's got a camera on it for IR imagery as well, okay, and it gets deployed out in the field and it communicates over TV white space. So television, you know, if you turn on a channel and you see that, that's white space. It's part of the television frequency spectrum that's not being used by some existing channel. You know, there's, what was the song, 99 channels and nothing's on or something? You can use that spectrum to communicate over quite long distances at low power. It's low bandwidth though, but it can go over long range, low power communications because of how the frequencies are relatively low, say compared to your cell phone or whatnot, okay? So you got to do some tricks to compress as much information in there as you can. And even with all those tricks, like it's not enough because you can only put so many of these devices out there. There's only so much bandwidth. So we need some way to augment to get a, you know, view of the entire field with higher precision, higher resolution. How do we do that? Any ideas? So I give you a field and I don't know, I put a grid of sensors on it. And they're spaced at whatever, 1,000 yards. So a pretty sparse grid. And I tell you we need, you know, 1 meter resolution of the microclimate. Any ideas how you would do that? No? Or just too shy to say? How about, no, I won't do that to anybody. So what we did was we said, okay, what if we have this grid of telemetry, what if we augment it with imagery, drone imagery? Then can we do a machine learning model where, you know, if I happen to have a sensor on this pixel, it can learn something about that pixel's image in relation to that sensor and maybe some neighboring ones. And if I collect enough of that data, I can actually develop a model that can fill in the blanks. So that's what we did. We used UAVs as well as, UAVs actually have some issues. They can be expensive depending on where you are. Say this is in India, for example. Maybe it's expensive there. Battery life, regulatory concerns, somebody shoots them with a shotgun, whatever, right? People don't like drones necessarily. So we have other things too, like tethered balloons. That's just, that's like a duct tape engineering idea. What if I just put a balloon with a camera on a truck and drive around? Okay, that's exactly what they do. They just drive around. And then that can collect imagery as well. Take all that, take these panoramas that get stitched together. There's a water puddle, cow dung, cow herd, stray cow. Okay, combine it with the telemetry data you get from the sparse sensors with some machine learning, and then you get this precision map. And it actually works. So, but we had to collect a lot of data to do it. But we can use machine learning to interpolate, to get a precision mapping of the local variables, moisture, pH, etc. Oh, by the way, plants as well, from aerial imagery looking at their leaves, we can gather information about the soil that they're growing in. Is that cool? Now, the bandwidth problem, what can we do there? Well, we have this weak connectivity, and this happens in a lot of places, not just farms. I mentioned ships, going across the ocean or whatnot. What you can do is put in the middle there a gateway that can do smart stuff. This is edge compute, right? So a gateway can sit there and it's an edge device. It can do calculations. It can do all kinds of fancy compression, statistical summarization, et cetera, so that little precious bandwidth that it gets, it can make the most of it. And if it ends up with some extra bandwidth, like let's say the ship comes into port, bam, offload all the data, right? This happens with airplanes. So one of my customers is United Technologies, aerospace. You can imagine airplanes fly around, they collect tons and tons of telemetry. Can't get it back reliably until they land and go to the hangar, offload it all, right? So we can do the same thing with these edge nodes. And by the way, it's kind of there is no the edge. There's edges. There's rings of things, right? There's many edges out there. And so you can have tiers of compute. Like for example, in a connected vehicle, you want a lot of compute local at an extremely low latency, highly reliable tier, right? And then there's the entertainment system that you care a little bit less about, and et cetera. So there are many edges. So this is kind of what the overall framework or the architecture looks like overlaid onto a farm. So you got the sensors, and they feed over TV white space to a gateway that does smart things and stores data. And when it can, it uploads it to IoT Hub, which is our product for wide, horizontally scaled communication. Okay, millions of devices, that type of thing. And from that, once it's up in the cloud, you can sort of do all your analytics and visualizations, and there's drones, okay, and they may interface with a different edge, so they may go fly their pattern, collect the data on the drone, come back, land somewhere with a good signal, offload it. This is what it looks like to create a connected supply chain for agriculture. And of course, there are subsequent, routes down the chain, obviously, like it goes all the way to genetic engineers that do massive high-performance compute to engineer things for microclimates.
So what motivated this application? Like, I don't think of like farming and Microsoft as a typical...
Altruism. So Microsoft is, I don't know, maybe it's the direction from Satya, but our new CEO, but we're looking for things to help the planet. That's why we're doing this. Now, we do have customers clearly that are, you can imagine who they are, I'm not going to name them, who are in kind of agricultural manufacturing business, right? They're interested in that kind of stuff, but they do a lot of proprietary things on their own anyhow, right? Farm Beats is our attempt to make it cheaper, more accessible to all parts of the world. We're a good company now. We're nice guys. So that's an architecture. I mean, look, I'm not gonna bore you guys with architectures mostly. I'm happy to give them. This is kind of what I do as part of my job, is create architectures. They're often, I can give you generic ones, but really what we do is manufacturers, it has to be one of the most diverse industries, I think. Because I've been in the financial industry and the manufacturing industry, and between those two, I can tell you manufacturing is far more diverse, right? You've got manufacturers with machines that are 100 years old, and machines that are 6 months old, and machines that cost $5,000, and machines that cost $50 million. Can you believe that, of one machine? Of scale from a device to things that are miles long, right? And building all kinds of stuff, electronics, food, chemical processes, whatever. So there's just a huge variety in the manufacturing industry. So a lot of what we do is we come in and we look at the specific situation they're in and the state that they're in and where they're at along that journey that we kind of outlined earlier, and help them design the best architecture specifically for them.
So in your experience, when you talk about that solution journey, is a tendency that a lot of those people are at the connecting stage?
Yeah, it's a good question. So most people are in the connect stage. So, look, manufacturers have been doing automation within the factory for a long time. So they have SCADA and all kinds of manufacturing engineering systems and whatnot. They know how to do IoT in that sense, but it's without the internet. It's more of like an intranet of things, okay? But the factories are isolated. So here's a factory in wherever remote China, and it's doing its thing, doesn't know anything about what some other factory's doing. And as we start to bring them visibility across factories, they find things and gain insight like, wow, same machine making the same thing at this factory has an operational efficiency of 86%, and this one's 72%. Who knew? Why? What can we do to improve the efficiency over there, right? Some time motion studies, is it some other issue? Is it humidity? I've had customers, different humidity. There you go, problem. Maybe we should control that. So you can gain insight just from having visibility across different factories in real time or near real time. So most of them are in the connect phase. Okay, on the other hand, I was in a call a couple days ago where after the call I chatted one of my peers and said, well, that's a first. I've run into a customer that's so advanced I don't know how to help them. And actually, I'm hoping somebody in this room can help me because they're at the phase where they're doing this mixed integer linear programming problems, optimizations for scheduling, right? They've already got the basics done and they're asking me how to model like certain aspects. I don't know how to model that. I know what Garobi is and I know sort of how to create basic models, but they've already done that. So maybe there's some expert in here. We can work together. So that was a first for me though, to run in, and they're really cutting edge. Like anytime we release something in preview, like private preview, oh yeah, we want that to be online now. So they're cool in that respect, but they're uncommon. Most people just need to connect their data right now and work on those beginnings of the journey. That said, that doesn't mean that you can't do advanced analytics with what you have, right? You don't have to 100% complete the first part of the journey in order to do the last. So, there's always this, I tell customers, they always ask, do we have enough data? And I say, look, I'm never going to come to you and say, oh man, you've only got 24 data points. If you had 25, I could help you. It doesn't work like that. The more data you have, you get greater certainty, better accuracy. Maybe the project will or won't work if it doesn't have enough data. But we can always start with what you have. And in fact, starting with what you have and doing the data engineering piece of it before the data science often leads them to insights. Like they discover things they'd forgotten about in the design. For example, error codes that they didn't know what they meant or that sort of thing. So you start with what you have, but most people need to do much more connectivity to progress further. This Farm Beats project, oops, I skipped past that. It's actually, we have locations all around the world. They're mainly in the United States or North America, let's say, and India. Okay, but that's just the pilot phase, right? So this is real, it runs today, we're doing this out there in the world. We're working with agrochemical companies as well to make use of this data or make use of this platform. Here's some statistics. We deployed 100 sensors, 10 cameras, 10 million sensor, so we're making progress, right? Again, we want to make the world a better place. Isn't that in some comedy show, like Silicon Valley or whatever? Everybody wants to make the world a better place. Ours is a little different. We want to help everyone achieve more. That's it, including you. This is an intermission for some Q&A, although I have less time than I had anticipated, so any quick questions? So we'll save the questions for the end because I'm going to be here all day till the flight. So, I'm happy to hang out and answer questions. All right, you can't give a talk that has chain in the title without talking about blockchain, right? Who wants to hear about blockchain? Okay, so that's the most hands I've had up from all the questions I've asked so far today. So we'll talk about blockchain. And originally I had made this title, Blockchain, Putting the Block in Supply Chain. And then I realized, no, we don't want to block supply chains. So it's now unblocking supply chain. That's literally actually what blockchain, and again, I said I'm an anti-hype person, right? So even though I mined some Bitcoin myself way back when it first came out, I'm telling you about blockchain because there are some real applications to it, not just because it's hyped. But believe it or not, hype itself is a valuable thing. So, let's talk first, I'll tell you about that more. Let's talk about what is a blockchain. What it is it's a secure, shared, distributed ledger. And a ledger is a type of database. So at its heart, we're talking about peer-to-peer auditable databases. In other words, a database where we're peers, collaborating in sort of a consortium. Maybe that consortium is everybody in the case of Bitcoin, or maybe it's a limited pool of commercial enterprises or whatnot. But the point is, we all kind of have, in a sense, standing in the database itself. We share it, we can audit it, but it's a database. That's what it is. It's a peer-to-peer database. Okay? And it's secure, uses lots of fancy cryptography, which I can actually talk about because I did study that for a little while till I realized the prerequisites actually were prerequisites and dropped it. Algebra, abstract algebra, same thing, right? No, not for me. They're distributed, but we've had distributed databases before, right? I mean, you can distribute SQL and have mirrors and all that kind of stuff, but it's distributed in the sense that it's distributed across entities. The trust is distributed. Shared, everybody has a copy or in principle. There's lots of details and various types of blockchains, but the best way to think about it is a peer-to-peer auditable database. And there are commonalities across the use. So we've been trying, blockchain, it's hyped, everybody wants to do it. And then we go and try and do these projects, and as customers dive into the details, maybe they figure out they didn't need blockchain, they just needed a database, right? Okay, but we've actually had successes, and in the ones where we've had successes, they've had these things in common. So they've had cross-organizational workflow. multiple parties wanted to be able to audit it, like a sort of trust boundary. Like suppose, I send you an order, and then I get back something else. And I say, hey, this is what I ordered, you gave me it. Well, that's not what you ordered. Here's our database. It says you ordered this. That's not what I ordered. Well, we can resolve that type of issue, that trust boundary, with blockchains, because we agree, hey, look, it's there. And by the way, and maybe this is in the next slide here, you don't have to put the whole order up into the blockchain, just FYI. Anybody know about hashing? Do you understand, familiar with the concepts of hashing or hash codes? So it's like any document is just a binary stream of data, right? And I can take this document, however long it is, megabytes, and hash it cryptographically down to something much smaller, let's say 1024 bits or 2056 or whatever, a hash. And basically it's, power 2 to the 20 or 2 to the 2056, which is like more than the age of the universe or particles in the universe or whatever. The two documents will hash to the same hash code. So if I say, here's an order and I'm going to send it to you by email, but I'm going to put the hash and I'm going to digitally sign it up in the blockchain, and then you confirm back, here's the hash that I've digitally signed. Okay, and then at some point if there's a problem, all I have to do is produce the document that gives that hash, and that's it. You can't counterfeit the document that's going to give that hash. All right, so let me just back up here. Cross-organizational workflow, trust boundaries. So you ask yourself some questions. Is there a business process that crosses boundaries? Do multiple parties work on the same data set, like an order, for example? Okay. Are there intermediaries that are trusted intermediaries that control the truth? Maybe we want to get rid of them to create efficiency. Okay, does it involve a bunch of low-value manual verification steps? Now this last one, a database can do that too, right? This is where the hype comes into play. It's like, look, maybe it's going to be hard for me to convince my suppliers to all adopt SQL or something, but I can convince them to adopt some blockchain because their CEO read an article and came in one day and said, I want some blockchain in this organization. That happens. I'm not kidding around. So you can take advantage of that momentum that the hype builds to get everybody to adopt a common platform. Make sense? And here's, like for manufacturing industry, here's some use cases of blockchain. So supply chain, and we're going to kind of talk about that in more detail. There's a whole bunch of other ones that we kind of run across. Some of these slides are sort of slideware in the sense that this deck will be made available to you. And feel free to peruse it and dig out more details. Bing or Google for it, and make sure you go to a Microsoft page though. And so for example, let's consider supply chain provenance and tracking. And we kind of already talked about that. We have some bill of materials, okay, and we create a hash of that, or hashes of individual parts, or a hash of the whole hash. Lots of hashing. And that sort of forms a digest, and from that we can verify authenticity, we can prevent counterfeiting, we can resolve disagreements between suppliers and their what's on the other side of a supplier? Somebody tell me. What's the opposite end of a supplier? Receiver? It's not a receiver, is it? Consumer. Thank you. Drawing a blank for a minute there. Consumer. Suppliers, consumers. You can maintain histories. Okay, what goods are being resold? But here's like kind of a more interesting one maybe. And we actually ran into this, almost this exact use case, except replace temperature with threat level, i.e. pirates, military instability, whatever. That was Maersk's use case for blockchain. They have to buy insurance for things that they ship around the world, and they have to pay more if they go through risky areas of the world. And there's always disagreements about that. Well, you guys went through the Suez Canal or this, or came too close to this country, so you owe us more, right? So, but you can replace here in temperature with that same concept, GPS location. Okay, let's say we got a shipping company and there's some temperature sensitive product, and we have sensors kind of at various carriers and warehouses and departure ports, and they can record to the blockchain what the temperature is at whatever interval is necessary, right? And so if something goes wrong, you know, there's a violation at some point, that gets recorded, we all agree that it happened, you know, we've all contractually agreed on what the sensors are, penalties if you tamper with them, et cetera. And by the way, most things there's really no motivation by the person operating it to tamper with the sensor. You know, imagine you're a truck driver and something goes wrong with the cooling unit, exposes the product to it. That's not your problem. I'm not going to go back there and tamper with that thing, right? And in fact, it motivates people to actually just report it because they know it's already been logged in the blockchain. Well, I guess we better report it, right? Makes things smoother to just have this agreed, trusted, common database, or ledger, if you will. The distinction between ledger and database is that ledgers aren't modified. So a ledger is just, you know, like an accounting ledger. New entries get added. You don't go back and erase them. So it's a append-only database. But not all blockchains necessarily need to be append-only, but again, technical details. Okay, this is what like a real, you know, platform looks like. Again, kind of slideware. I'm going to let you just look at that for a minute. You can look at it in much more detail. This Visix is a platform for IoT, collecting IoT sensor telemetry. And then we layered on top of that a blockchain application. Okay, now, this was another example of supply chain. I'm going to skip that in the interest of time. What I want to tell you about is what we're doing to try and make it much easier for customers and you and anyone to play around with blockchain. Because right now, if you go and try to build a blockchain application by yourself, you've got to do a lot of things. Here's like a kind of honeycomb of the stuff you have to do. And I'm talking about you go and download the source code to Ethereum or not Ethereum, you know, whatever, Corda or Ethereum, I don't care. And then you try to go and do some custom blockchain deployment. All right, you're going to have to worry about identities. Okay, identity is the new security perimeter, in Microsoft's opinion. Okay, it's all about identity, multi-factor authentication, encrypted communication, right? So you're going to have to deal with identity management. You're going to have to integrate the business apps, configure the network, deploy the ledger. This is the interesting part, write some business logic. You're going to have to worry about a lot of things. So what we've been trying to do for a while now, a couple of years or something, is make this much easier to do. What have we done? Well, we populated pre-configured networks and network topologies that you can deploy in Azure as just things from the marketplace. Okay, we've integrated lots of our cloud services, provided integrations into those APIs. We built a simple interface called Blockchain Workbench. It's going to come up later. Okay, we support whatever interesting blockchains are out there. You can choose, we don't care. These are just integrations with our existing, you know, API management and whatnot. And we put this all into what's called Blockchain Workbench, which you can go check out. And it's really just, how many of you have an Azure subscription? Okay. I think you can, I don't know, maybe as students you can get some sort of a free trial or something like that. Check it out because, you know, the best way to learn this is just to go in the portal and try stuff out. And I think the school itself, well, anyway, we'll see. But I think you should try it out or, you know, see if you can at least. It's literally just you deploy some stuff, you click some boxes, and now you have a, you know, a consortium network sort of set up. And you can start writing applications. So you only have to worry about, that's kind of what the architecture looks like. You only have to worry about the cool stuff, which is just your custom integrations. So maybe you're a commercial enterprise and you have some proprietary application. Okay, we need our developers to worry about that integration we can't do it. Microsoft Consulting Services can do it, but we don't have it out of the box. So your custom integrations, the business logic is obviously what matters, and then extending beyond the capabilities that we provided. That's really the stuff you want to work on, right? Not all that other stuff. That's what Azure Blockchain Workbench, and if you want to learn more, there's some links. And in the presentation, these are hyperlinks, so you can follow them. All right, AI for all. Hopefully I still have some time to talk about that. Yeah. What is our mission? It really is about AI for all. It's about making AI much more accessible to all levels of the AI stack, okay? Not by making it, did I say less accessible? More accessible, okay, to all levels. Not by removing capability, but by wrapping capabilities at sort of higher layers of abstraction. So for example, we have something called cognitive services. And if you just search for Azure Cognitive Services, it'll take you to the page where you'll see these different categories: vision, speech, language, search. What that is, for example, people have been working on speech recognition for a long time. Right? Almost as long as they've been working on chess for computers, they've been working on speech recognition. Okay, so there's a lot of knowledge compiled into techniques and models and even specific neural networks and things like that that do well at speech recognition. So we package those up into a service, okay, where you literally just have to upload samples and tune the prepackaged models for your specific use cases, or just use the default. If we've got that language available already, use the default packages that are up there. It's very easy to utilize, and these are all just behind URLs, basically, is the way it ends up being a web service, right? So since it ends up being a web service, you can access it from literally anywhere, any kind of application. It's very easy to build applications that utilize these services. Same thing with vision. People have been working on computer vision for a long time. And we have these prepackaged things. You literally just create folders with the different tags or labels you want to learn, upload photos. And the cool thing about the pre-built models is that, and I'm roughly speaking here, they're kind of utilizing what's called transfer learning. The idea that, look, from massive data sets, we've already learned a lot. And that can just be through, hey, convolutional neural networks work better than LSTMs for image recognition, or specific network structures like ResNet, which is the one Microsoft developed, and for a year or two or something, we were the best vision recognition neural network. Okay, so that knowledge is packaged up in these models, so you need very less data to tune them for your use case than you would otherwise. Make sense? Because when a neural network learns how to recognize images, it has to learn all types of fundamental things like what a corner is and a line and that sort of stuff. It's already kind of built in. Then if you want to go sort of a layer below that, we provide all kinds of tools in which you can do development. Pick your tool, whatever you want. Jupyter, PyCharm, Visual Studio Code, doesn't matter. We support the popular frameworks. Here's, our competitor obviously created TensorFlow. We like TensorFlow. We like it when it runs on Azure. So we think it runs best on Azure. Try that out. And then also we have these services that let you do data science, where you're really trying to explore and do research and build models. Okay, so Databricks is an implementation of Apache Spark, which is essentially just a platform for distributed compute, for efficient distributed compute. Really kind of a successor to Hadoop, and it runs on top of Hadoop. It just does a lot of caching, to make things faster, intelligent caching. It's kind of optimized for Azure. It has a really nice experience in Azure, but you can run Databricks elsewhere as well. And Spark, obviously, open source, run wherever you want. Azure Machine Learning Service, oh, by the way, we have all kinds of cool hardware you can try out. Instead of you going and buying a bunch of FPGAs, you just spin them up in the cloud and see if your learning problem performs better on FPGAs. Some do, some don't. Try it out and see which one is cheaper, right? But I want to tell you more about Azure Machine Learning Service. So what it is this environment for doing the steps of data science, which is model creation and training, keeping track of your models, which we call a model registry, and keeping track of how well they performed, and you can deploy them from the registry because they get containerized. Okay, here's where you can deploy them to the edge. You can deploy them to the cloud, monitoring their performance and things like that. It's this whole life cycle of data science is what Azure Machine Learning Service is about. And I want to just show you kind of one cool component of it, which is we have this visual environment. It used to be called Azure Machine Learning Studio, and that merged with some other products into this Azure Machine Learning Service, and now it's called Azure Machine Learning Visual Interface. I like Studio personally better. I thought it was a better name, but I'm not in marketing. But I bet that wasn't data-driven, that choice of name. So it's literally drag and drop. And I told you, as you heard, so I was doing Wall Street quant stuff for the better part of 8 years. And it was hardcore. Okay, that's why my hair is gray and I'm out of there, because it's hardcore competitive, right? So I'm like hacking the Linux kernel and using all kinds of applied math and numerical analysis packages and whatever. This thing here actually made me enjoy machine learning again, because that's a lot of work, right? That stuff. This I love because I got this library over here. I can drag and drop, hook up components, try out different models, see how they perform. It's got built-in visualizations of the performance. Oh, and you can use this for free, by the way. There you go. Okay, go try this. Azure Machine Learning Studio/Visual Interface. And if you search for Azure AI Gallery, you'll find this awesome website where we have tons and tons of sample of all kinds of things, but including experiments for Studio that you just can use the free version to go and deploy and try out, okay? But, it actually is not a toy. Behind this is whatever arbitrary machines and power you want to run it on, okay? One click to deploy it as a web service that comes with its own web page portal and stuff where you can see it and everything. One or two clicks or something. It's 1 or 2 clicks. I think it'll ask you to run the experiment if you haven't already run it, and then you can deploy it, because it wants to make sure it works. And not only does it have that awesome interface, but you can actually put in custom code. So for example, I was so glad we had this product because I'm going to skip past this for 1 minute. I'll come back to automated machine learning, because not long after I started at Microsoft, I got this call from some account team, and they're like, oh, this customer, they're really upset because they found a Microsoft partner. We didn't suggest a partner to them, but they found them somehow. They have this problem. They're trying to predict industrial chiller load, the load on industrial cooling chillers, based on all kinds of variables. They had temperature, humidity, wet bulb temperature, et cetera. Okay, then I'm only doing a 2-dimensional slice of that space just to kind of show you what the linear fit was. And they're really upset. It's only doing 47%. They can't do any better. They're going to, I don't know, they're not going to be our customer anymore. Can you do anything? And this is a Friday, by the way. Yeah, sure. Send me the sample data and I'll see what I can do. Thank God that I had Visual Studio or AML Studio. I would have gone nuts if I actually had to go and do all this from scratch, right? And start banging out some Python, all the Python code. As you'll see, I wrote some Python code. But anyway, I got this sample data and I'm sitting here going, okay, well, I'm going to assume they did the basics. How about this? It's supposed to be a building of some kind. Maybe there's a workforce. And anybody who's been in a small apartment room when there's a big party, People generate a lot of heat. All right, I'm going to hypothesize that there's workforce body heat and it's contributing to this unpredictability. So I'm going to write some custom, I'm going to create a latent heat variable for every hour of the week, okay, and fit it using AML Studio. So I went and created the model here, and I wrote just some Python code, and it's only about like that long. It's only sort of a page and a half of some Python code that creates that thing, those latent heat variables. Okay, and did the fit, and I plotted the latent heat as a function of time throughout the week. Wow. Cool. Something neat, Look at this. This is 9 a.m., 5 p.m. Apparently there is some kind of workforce that comes in quite a bit before 9, and they generate heat, and they're all out of there by like 3 o'clock or something. And this is not, if anyone's ever looked at solar irradiance patterns, they look exactly like this too, but it's not, because the sun doesn't care about Sunday and Saturday, despite the name. Okay, so this is not a astrological phenomenon, or whatever, is that the right word? That sounds like astrology. I don't know. Did I say it right? But I hope so. It's not the sun. It's obviously some type of human-generated thing. And what I thought was kind of cool too is Monday, Wednesday, Friday. It's kind of bigger than Tuesday, Thursday. Now I didn't know what kind of building this was, but you're smarter than me, okay? What kind of building do you think it is that has slightly more people on Monday, Wednesday, Friday, trends down throughout the week, and people kind of come in before 9 and leave well before 5? A university. Classes start at 7. You got, plant maintenance and all kinds of people that come in before that, right, and do things. The professors are obviously out of there at like 2 or something. The students are probably with some TAs, and it trickles down. Monday, Wednesday, Friday, right? Probably the most common class schedule. And Tuesday, Thursday, the other schedule, right? Bingo. I asked them after the project, what kind of building was this? Yeah, it was a university. They wouldn't tell me ahead of time because they were upset about the previous work. Then I showed them this, and they were like, oh, wow, this is awesome. Didn't even know you could do that in Azure. And to this day, they're using AML services. They love it, using it to deploy the web services that can gather the telemetry and spit out the predictions. And it improved it, it went from 47% to 62%. That was only one building, 1 year was all they would give me. It got much better as we refined the model. I think there was something I skipped that I wanted to talk about. Let's go check real quick. Oh yeah, automated machine learning. So now it's even easier because used to be data scientists like myself or others, we kind of had our sort of recipe of things that we would try. Like, well, I'm going to try, my favorite things that seem to work usually are logistic regression, linear regression, decision trees of various structures, certain types of neural networks, depending on the problem, right? That's a lot of work to go through that. We can automate that. That's just a cookbook. Try this with this hyperparameters and that. That's all automated machine learning is, okay? ML is not magic learning, despite, we're not at the point where you just go, Cortana, make my business more profitable. Okay, I can help you with that. Not there, okay? People are an essential component of machine learning. Despite the name, people are an essential component. These are human-derived recipes that we have found over time work well, okay? And it's just going through that cookbook, but it does it in, seconds versus lots of time for you to set all this stuff up, okay? And furthermore, as more and more people use it, the recipes get better, right? That's what automated machine learning is, and that's part of Azure Machine Learning Services as well. So now all you need to do is just kind of upload your data. So a lot of times you'll have to do some data engineering. And if there's any of you out there who are data scientists or you want to be a data scientist, don't be surprised that you're going to be spending 80% of your time doing data engineering, i.e. cleaning, integration, et cetera, right? I read an article that there's all these disappointed data scientists. They went out to get jobs, and all they're doing is data cleaning. Sorry, they didn't tell them that in school. That's reality, is the engineering piece is a lot of the work. It's not just like, yeah, give me all your clean data, and I'm going to create this cool model. Actually, we automated that, right? Don't need you anymore for that. It's the data. No, you still need, it's very much a human-driven process. But this is a first pass, and then you can refine it. Okay, let's see. I think we're about at the end here. Oh, job shop optimization. I just want to run through this really quickly because I'm looking for help on this. If there's anybody out there. What is job shop optimization? I'm going to skip past a little bit. Think about it this way. Suppose, that used to be animated. Well, anyway, suppose you're a high mix, low volume manufacturer, which means you make, and by the way, this is becoming more and more common, you make things that have a ton of variety and you do small runs of it. So somebody wants a cable that has 3 red wires and 7 yellow ones and 2 blue ones twisted in this way with this kind of sheath. Okay, so you manufacture that, right? You have machines that can do that. But you got a bunch of orders. Like somebody wants red and green and somebody else green and whatever, different combinations. And anytime you change a machine from one to another, there's so-called setup costs for that, right? And the more you have to change, the more expensive it is, the more wear on the machine. And this applies in a lot of industries. I said there's more drive towards high mix, low volume. Think about windshields on cars. I think they used to just be like a certain size and flat or something. Now it's like, oh, we found a slightly better aerodynamic profile that has this spline that's 0.1% different than your spline, and that's competitive. Now we need a new windshield SKU, right? Because it's slightly different. So this is applying in a lot of industries, okay? But the problem of finding the optimal path, through here, i.e. scheduling certain runs on this machine to optimize order, on-time delivery, cost, reduce wear on the machine, et cetera, is a very hard combinatorial problem. You can imagine it sort of grows with exponentially or factorial or whatever with the amount of stuff involved, okay? And the way a lot of manufacturers currently do this is sort of they have heuristics and they kind of semi-manually do it, which is okay. Like they've learned how to do that over time. The problem is stuff changes, like a machine breaks down, or somebody calls in sick, or an order gets canceled, or a bunch of new orders come in that are rush deliveries, right? And it's hard for people to quickly adapt the system efficiently, right? So this problem of solving, we worked with a customer to do this computationally, okay? And what it did is, they have their kind of machine specs and orders. That gets uploaded into the cloud as just like blobs and files and whatnot. And we have like data factory and scripts and things that clean it up and put it into a form where, in this case, it was Garobi, but it could do whatever, just any kind of mixed integer or linear programming optimizer. It kind of does a first pass and gives them a schedule. That's the initial solution. And by the way, that goes out and they approve it. But in the background, they choose a certain amount of money they're willing to invest in continually looking for refinements, trying to refine this schedule. And if it comes up with something, because this problem is not solvable, I didn't mention that up front, but beyond a certain complexity, you will not solve this problem in any amount of time. But you can quickly find pretty good solutions. Like you can get quite good approximate solutions and go ahead for now, but you can work on finding better ones. You can refine them, okay? And so if it finds a better one, then it reports back, hey, I found a better one. It's 0.5% better. It'll save you X and cost you this much. Do you want to transition? Go ahead. I'm going to keep looking. Right? And you can, by the way, scale that up to however much compute you want. You want to spend $5,000 a month looking for better schedules? $50,000 a month? That's what I love about the cloud. It's totally tunable. How much do I want to? Cloud is making everything about what you get for the dollar. Which, being a former Wall Street guy, I'm like, yes! It's the way it always should have been, It's all about, I can get this done for $5. Or I can get this done for 10, right? It's all become about the dollar. Because for any computational problem, more or less, you can scale up whatever kind of machine. We have machines now, I forget what we're up to, but it's some insane number of cores, like 2,000 cores or something. Or you can do distributed compute things at whatever scale you want, or HPC. We have like HPC stuff you can rent to, FPGAs, you saw it all. Okay, you want it done in an hour? You can do that. And actually it won't cost you that much more than waiting 4 days for it if you set up the infrastructure to do that. It's just you're computing the same amount over a longer period of time versus a shorter period of time, right? So that's a cool thing for this type of problem, because you can scale up to whatever meets your business needs. And if something happens, like a line goes down, oh, hey, spin up the powerful machine. We need a new schedule by the end of the day. No problem. Try to do that on an on-prem cluster. You're going to be paying for that scale of a cluster all year long for the rare times that you need it. So I'm hoping somebody out there loves, job shop optimization and will want to work with us to do that kind of thing, or help us know how to do it better. Because I said before, I ran into this customer so advanced I don't know how to help them. One last thing is, we talked about the importance of edge. All I wanted to tell you really here is that there's all kinds of edges. Edges can be very low compute, very low power. They can be quite beefy sorts of things, right? You need to think of it as kind of having rings and tiers of edges that can be tuned for the business purpose. That's it. That's it, folks. That's the end of the talk. So I'm here for questions. Yes?
Just at a really high level, when you look at the convergence of data, cloud tools, business apps, business tools, blockchain, and so on, how do you position? You see what Amazon's doing, changing the retail game. You see SAP, Oracle, IBM, blockchain. How do you think about your ecosystem?
Yeah.
You got to be friends with some people.
Yeah, so good question. So the question is, with all the kinds of innovation and consolidation, how do I see Microsoft's position amongst, like, let's say, there's really only three, hyperscale cloud vendors. There's Amazon, Google, and Microsoft, right? So among those three, for example, and I don't mean this to be insulting at all, okay? Because look, there's a lot of variety of life. There's niches to fill everywhere. Amazon got there first. They're a hyperscale cloud provider that also sells groceries and books. Google is a hyperscale cloud provider. Their bread and butter is web marketing, right? Yeah, they have G Suite. Used to use it before I came to work at Microsoft. Doesn't really compare feature-wise to Office, right? Microsoft is a hyperscale cloud vendor that has the world's #1 productivity suite. We write operating systems. We have database. We have a great Microsoft SQL database server. It's been around a long time. We have a broad and deep software engineering history and talent pool and stack. So if you think about IaaS, infrastructure as a service, and then on top of that is PaaS, platform as a service, and on top of that SaaS, software as a service, as you go up that stack, and this is borne out by the data, Microsoft gains market share. we are a software provider, first and foremost, okay? So the way I see us is if any of those companies is positioned to deliver software as a service solutions, we're best positioned to do that. So I think what you'll see is that as people start to care less and less about IaaS and PaaS and much more about the software that they're getting, you'll see Microsoft, playing the dominant role. Does that answer your question? Okay. Yes.
First off, fantastic presentation.
Thank you, really.
But a corollary to his question, there are a number of vendors across all of those industries that are already there and embedded.
Uh-huh.
So you have John Deere, in manufacturing, you have Rockwell Automation,
Oh yeah,
Autodesk. They have all of the proprietary data sets, and they're thoroughly familiar with all of the problems that their customers have, and they have a distribution of data
Yep.
globally, historically, and on top of that, they have institutional knowledge ahead of time. That said, as you look forward into the future in a more caustic economic environment, do you think that Microsoft will have the commitment to solve those problems? Because those problems are extremely complex, and it's a reason why Autodesk or Rockwell Automation focuses on just a few problems, and they don't really focus on actually helping their customer.
Yep.
So I was wondering, how are you guys going to handle that?
Yeah.
Because it's very hard.
Yeah, awesome question. I don't know, did everybody hear the question, or should I try to do my best to repeat it? The question was like, look, in a lot of these spaces you've talked about, there's already companies that play in that space. Rockwell Automation, great example, okay? Very hard problems, they focus on niches. What's Microsoft going to do? Do we have, let's say, the fortitude to stick with it? Here's the thing is, we don't want to do this alone. Rockwell is a big partner of Microsoft's. Our goal is actually to just help foster an ecosystem of partners and companies and individuals, for that matter, to build these solutions. So anytime a customer comes, especially to the industry team that I'm on, and they have a problem, we first look to our partners. What we try to do is pair up. So we go in, we discover what the business needs are, what the challenges they're facing are. We try to help them brainstorm, envision solutions, design architectures. Our goal is always to pair them up with the best fit partner for that solution, which may be Rockwell, or it may be a combination of partners. Microsoft does, we're not really trying to be the company that provides all solutions. We're trying to be a company that provides platforms and tools for other entities to build and deploy solutions. Okay, that said, we do have a couple areas where we actually perceive there to be gaps that we're very aggressively trying to build solutions, AI and machine learning being one of them. So we've been including AI, building in AI into our software products now for a while. Maybe you've seen, if you go into PowerPoint, it can actually, if you've got a certain version of Office, it can design slides for you and make suggestions for you. There's a feature in Outlook. I don't know if it's public yet. Sometimes we get things internally, and it's hard for me to tell whether you have access to it or not. But the calendar or Cortana calendar help, is that available? That's who schedules all my meetings. I just send an email that says, hey everybody, want to talk about this? Cortana, please set up a meeting either Thursday or Friday. And it analyzes everybody's calendar, sends emails with suggested times, you reply back in natural language, bugs people if they don't respond, all the good, exactly what an assistant should do, right? And schedules my call, right? Oh man, saves me so much time. That's artificial intelligence, right? So in these areas of artificial intelligence, we have a very, very, very strong commitment. And I'm virtually certain that we're going to be in that space for years to come. For other things, we want to leave tons of breathing room for innovation and partners. Does that answer your question? Thank you for the question. Yes?
Can you
Right. So we actually we have the beginnings of some digital twin frameworks in Azure. The infrastructure is one, the connectivity. That can come about, the right connectivity is complicated. It depends on, as you saw, is it a farm out in the middle of nowhere? Like how's that? But let's assume you've got some channel of connection, okay, from which the information, you need a module that runs on the device that's collecting the telemetry and packaging it to send it up. I probably have an architecture slide to send it, up to the cloud. I'll just, there we go. So, you have to have some type of device, some type of edge that's packaging the data. Okay, it's going to get communicated maybe to a gateway if you need that kind of intelligence at the edge or buffering, that sort of thing. From there, it's going to go, say, up into Azure IoT Hub. Okay, and this is just a reference architecture, so that's one solution. IoT Hub is just the interface layer for communicating, mini device information to the cloud. Okay. Once it goes in there, all you really need to do is store that. Now, there's lots of options for storage, but for high value small data sets, like the type you're talking about, like the current state of a machine, that's something that goes great, and it's not actually up here. I guess I grabbed an old version. Cosmos DB. So Cosmos DB is our database offering that provides real-time SLAs. So the service level agreements say you will get a response within X milliseconds. It has all kinds of, it's a global database, as in planet scale database, and you can choose the consistency models that you have for local copies versus other copies spread around the world. Okay, so for high value snapshots, they would most likely go into Cosmos, and then from there you can visualize it however you want. And for example, in Azure you can create triggers off events happening in Cosmos. So like a data field gets written to Cosmos, an Azure function, which is our Lambda sort of architecture, our serverless compute, can fire off and do something, right? A Power BI screen can be visualizing that, or a Node.js application, or Microsoft Signal R, which is our .NET framework for real-time, visualization. That's really the minimal components for a read-only digital twin. If you want to be able to modify the stuff in there and have it go back, you need an interface in which you can modify, which is again just Signal R, Node.js, whatever. I change a field, I click a button or whatever. Okay, you need an Azure function that it communicates to, and IoT Hub is bidirectional. So we'll go back down to IoT Hub, down to the device. Is that what you're asking?
Yeah.
Okay. Yeah. Yes?
Could you tell us your vision on impact on energy consumption and storage space of the application of blockchain to supply chain? I'm thinking that some supply chain that we deal with in the industrial engineering school, they create billions of transactions a day, and
Yeah.
you have to keep that ledger over many nodes for hundreds of years. How would that impact in the storage issue?
Yeah. So the question was, for particular kinds of blockchains, how would we deal with the problems of scale, transactional speed? That's why we're not using Ethereum or Bitcoin, blockchain or whatever, because those are the issues that enterprises face. Okay, like if you look at the number of transactions that goes through the Visa network, it's some insane orders of magnitude higher than what Bitcoin or Ethereum can do, right? So the types of blockchains that Microsoft builds are really these consortium blockchains that are designed, for the purpose. And the reason why that's important is that if you have a trusted consortium, okay, so a group of X or N companies that have agreed they're going to participate in this consortium, you can still have all the goodness of identity, authentication, multi-factor, security, and whatnot. Okay, so they can give up on a lot of the proof of work and things that slow down the blockchains you're familiar with. So there's other kinds of consensus protocols that are much more efficient, much faster, that you can use if you're within a trusted consortium. So for our enterprise applications, that's what it's all about, is trusted consortium blockchains, not public, slow kind of blockchains. Questions over here? This is the quiet side, or it's maybe I'm just biased to look this way, I don't know. No questions there? Questions here?
Actually, yeah. You talked about the hype cycle some. In your opinion, is there something that you hear a lot of your clients and companies talking about today that you feel is maybe a little bit overhyped or maybe just misunderstood? So people are thinking that
Quantum computing.
Okay, can you say more?
Yeah. So quantum computing, there's this misconception that all computational problems will be solved once we have quantum computing. That's not the case. Okay, and actually the school has some brilliant computer scientists. Maybe you're in some of those classes. If you're in kind of learning about computational complexity, you'll find out, you probably heard the phrase NP complete, things like that. So there are these complexity classes that are kind of nested and sort of overlap in these sort of Venn diagrams. Okay, quantum computing enables you to solve a very small piece of that space very quickly. So it's like, it didn't take, like in the sort of blockchain or cryptocurrency world, right? When people really started worrying about quantum computing, it took them like overnight to have quantum proof encryption algorithms, right? It's no problem. Like some of the oldest encryption algorithms are quantum proof if you put enough bits in them. Well, it's not a bit related thing, but some of the oldest, algorithms. So there's a class of problems, and in particular a very important class. Okay, one of those is, for example, simulation of quantum mechanical systems. So for example, protein folding is a very difficult computational problem, right? And it's important. Being able to predict protein structure has huge impacts in pharmacology, right? So it can solve a set of problems that are really important to us. We don't have to worry that Skynet is going to arise as soon as quantum computing comes out. Yeah.
Thanks.
Sure.
Hey, let's take a minute to thank Keith for coming down.
Oh, it's my pleasure, really.